we are supposed to find the equation of a line passing through a particular point and which is also parallel to the given vector B. If A, B, C are the direction ratios of a given line, then the Cartesian equation is x minus x1 by A is equal to y minus y1 by V is equal to z minus z1 by C. So component form is again a Cartesian form, and vector form is only just you're representing vector A minus vector B, vector A plus vector B. So that is your vector form. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study about the equation of a line in three-dimensional axis, that is, equation of line with respect to x, y and z axis. So, in first PUC, in a straight line, you have studied the slope of a line, equation of a line in two-dimensional. Generally, we write the equation as ax plus by plus c is equal to 0 with only two coordinates. So now here in three-dimensional geometry, we are going to study the equation of lines in three-dimensional axis based on the given conditions. Now, one of the derivations here is equation of a line through the given point and parallel to the given vector B. So these are two important conditions to know that we are supposed to find the equation of a line passing through a particular point and which is also parallel to the given vector B. So this derivation is very important for 5 marks in your examination. So from three-dimensional geometry, you will get one derivation for 5 marks, and one of the derivation is this. So derive the equation of a line in space passing through a given point and parallel to a given vector, both in vector as well as the Cartesian form. We know that all the vectors have two forms. One is the vector form, another one is the component form. So component form is again a Cartesian form, and vector form is only just you're representing vector A minus vector B, vector A plus vector B. So that is your vector form. Now here I have taken a three-dimensional axis, x-axis, y-axis, z-axis with origin O. Now I will consider a straight line which is passing through the point A. Thus, we can say here vector from O to A, from origin to A represents the position vector of the point A. And consider vector B which is parallel to the given line L. Again, consider an arbitrary point P on the straight line L such that its position vector is OR. And clearly from the figure we can see here vector AP is lambda into B. Why? We know that when two vectors are collinear or parallel, their components will be in the proportional. That is, we have written A1 by B1 is equal to A2 by B2 is equal to A3 by B3 is equal to some lambda. So this is the condition for two vectors to be collinear. So that is their parallel. Now since here vector AP and B are parallel to each other, we can write vector AP is equal to lambda into B, where lambda is any real number or which is a scalar quantity. Now what is the position vector of AP here? AP can be written as vector OP minus OA, which is equal to lambda into vector B. What is vector OP? According to the diagram here, it is vector R, and OA is vector A is equal to lambda B. So thus we can write vector R is equal to vector A plus lambda B. So this is the vector form of the equation of line. So you are supposed to write the explanation also before writing this derivation. So what you are supposed to write? So first consider a line passing through point A whose position vector is vector A. Consider vector B parallel to the given line L. Consider any arbitrary point P whose position vector with respect to origin is R. Then clearly from the diagram is what we get vector AP is equal to lambda into vector B, where lambda is some scalar quantity. We know that AP can be written as OP minus OA. OP is R, OA is A and lambda B. Rearrange the term. So this is your vector form of the equation of line which is passing through the point and parallel to the given vector B. Now let's write the Cartesian form of this expression. So now as I said, let A be a point on the line. So let x1, y1, z1 be coordinates of point A. Next, let A, B, C are direction ratios of vector B. Next, let x, y, z be coordinates of point P. Now this is what we have to take. So now in vector form, vector R is equal to vector A plus lambda into vector B. Now what is the component form of vector R if the coordinates are given? That can be written as xi plus yj plus zk. So this is the component form of vector R. What is the component form of vector A? It is x1i plus y1j plus z1k plus lambda into, what is the vector form of vector B when its direction ratios are given? So direction ratios are given means it is AI plus BJ plus CK. Now here we have xi, x1i which can be written as x minus x1 into I. Similarly, y minus y1 into j plus z minus z1 into k. So that is can be written as lambda into AI plus BJ plus CK. So since here two vectors are equal, I can write x minus x1 is equal to lambda A, y minus y1 is equal to lambda B, z minus z1 is equal to lambda C. Or I can write x minus x1 by A is equal to lambda, y minus y1 by B is equal to lambda, and z minus z1 by C is equal to lambda. Now we have all the three equals to lambda. That means they are in proportional. So therefore, x minus x1 divided by A is equal to y minus y1 divided by B is equal to z minus z1 divided by C is equal to lambda. So they're all equal to lambda, and hence this gives you the Cartesian form of a equation passing through a given point and parallel to the given vector. So thus R is equal to A plus lambda B is the vector form, and x minus x1 by A, y minus y1 by B, z minus z1 by C is the Cartesian form of the line passing through given point whose coordinates are x1, y1, z1, and A, B, C here represents the direction ratios of vector B which is parallel to the given line. Now as I said, if A, B, C are the direction ratios of a given line, then the Cartesian equation is x minus x1 by A is equal to y minus y1 by V is equal to z minus z1 by C. So if suppose LMN or the direction cosines of the line, then the direction ratios can also be replaced with LMN. So the equation of the line whose direction cosines are given is same as x minus x1 by L, y minus y1 by M, z minus z1 by N. Find the vector equation of the line which passes through the point 1, 2, 3 and it is parallel to the vector 3i plus 2j minus 2k. So here we need to write only the vector equation. So the point is given, that means point A is given, and parallel to the vector is given, that is vector B is given. So first let us write what is A. So we can write here vector A. So for the point A, OA is the position vector which is vector A. How we can write this? I plus 2j plus 3k. And vector B is already given here. That is vector B is equal to 3i plus 2j minus 2k. Now we know that in a vector form, the equation of a line is vector r is equal to vector a plus lambda into vector b. This, what is vector a? I plus 2j plus 3k plus lambda into 3i plus 2j minus 2k. So this vector r is equal to, so we can also write xi plus yj plus zk. So this is the vector form of the given line. Find the vector and the Cartesian equation of the line through the point 5, 2, minus 4 and which is parallel to the vector 3i plus 2j minus 8k. So here vector A is given. So the point is nothing but vector A and parallel to the vector, that is vector B, is given. So we know that vector R is equal to vector A plus lambda into vector B. Just write its component. So vector R is equal to, we can write 5i plus 2j minus 4k plus lambda into vector B is 3i plus 2j minus 8k. So this is our vector form. Next we will write Cartesian form. So Cartesian form is x minus x1 by a is equal to y minus y1 by b equals z minus z1 by c. So x1, y1, z1 means the points of A. A, B, C means the direction ratios of B, that is 3, 2 and minus 8. So this implies x minus 5 divided by A is 3 here is equal to y minus y1 is 2 and B is 2 there is equal to z minus z1 is minus 4, minus of minus 4 becomes plus 4 and C is minus 8. So this is the Cartesian equation of the given line. The Cartesian equation of a line is x plus 3 by 2, y minus 5 by 4, z plus 6 by 2. Find the vector equation of the line. We need what is vector A, whose coordinates are x1i plus y1j plus z1k, and vector B whose direction ratios are ai plus bj plus ck. Now according to the vector equation, so the equation is x minus x1 by a equals y minus y1 by b equals z minus z1 by c. So comparing to the standard equation, we have here x1 as minus 3. So it is minus 3i and y1 is here 5 only. So plus 5j. And what is z? Z1 they have given us plus 6 but the value should be minus 6. Here we have minus, here we have plus. That means the value of Z1 is 6. Next we need ABC. ABC is 2, 4 and 2. So it is 2i plus 4j plus 2k. Now what is the vector form? Vector form is vector R is equal to vector A plus lambda B. So therefore I can write it out. Here also we can write R as xi plus yj plus zk, which is the vector form or component form, but we are writing in the vector form. What is A? Minus 3i plus 5j minus 6k plus lambda into 2i plus 4j plus 2k. So this is the vector form of the given line. Next one, find the Cartesian equation of the line which passes through the point minus 2, 4, minus 5 and parallel to the line given by x plus 3 by 2, y minus 4 by 5, z plus 8 by 6. So since it is passing through the point, we can take x1, y1, z1 as minus 2, 4 and minus 5. And they have given the line is parallel to this line. Which line? X plus 3 by 2, y minus 4 by 5, z plus 8 by 6. So when the two lines are parallel, their direction ratios will be same. So therefore, the direction ratio of the required line is also 2, 5, 6. So we can say the dr of vector B we can take it as 2, 5, 6 because they have given the line is parallel to another line. So therefore the direction ratios will be same. And we have here the point here. So now we are supposed to write the Cartesian equation of the line. So therefore we have x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So here x1, y1, z1 is x minus of minus 1 is x plus 2, y minus y1 is y minus 4, z minus z1 is z plus 5. So since I said direction ratios will be same for both the lines since they are parallel, here also it is divided by 2, divided by 5 and divided by 6. So this is the Cartesian equation of the line which passing through the point and parallel to the another line. Next, find the Cartesian equation of the line parallel to y-axis and passing through the point 1, 1, 1. So we know that the direction cosines of y-axis will be is 0, 1, 0. So therefore, the equation of any line passing through y-axis, so the equation of line so parallel to y-axis will be always, there is no, it is 0, 1, 0. So it is x by 0, y by 1 and z by 0. So this is the equation of the line. Now the given line is passing through the point. So according to the Cartesian equation, it is x minus x1 by a, y minus y1 by b, z minus z1 by c. Since the line is parallel to y-axis, the equation remains the same, but the point become, so since line is passing through 1, 1, 1, the equation of line is, so here it becomes x minus x1 which is nothing but 1 by 0, y minus y1 is 1, z minus 1 by 0. So this is the equation of line parallel to y-axis and passing through the given point. Next, find the equation of the line in vector and Cartesian form that passes through the point with position vector 2i minus j plus 4k and is in the direction of I plus 2j plus k. So here passing through the point means usually they would have given the points in the form of 2, minus 1, 4 and we know that any point can be expressed in terms of vector. So therefore here component form of a point is given. So therefore here x1, y1, z1, x1, y1, z1 is nothing but here 2, minus 1, 4. Now, and it is in the direction of the given vector means it is parallel to the vector. So here vector b is given, that is I minus 2j plus k. So we know that vector form is vector r is equal to vector a plus lambda into vector b. So vector r we usually write it as xi plus yj plus zk. Vector A is already given, so which is 2i minus j plus 4k plus lambda into vector B is also given, that is I minus 2j plus k. So this is the vector form of the given equation and here we are going to write the Cartesian form. So Cartesian form is x minus x1 by a, we know x1, y1, z1, x minus 2 by a. What is a? The direction ratios of vector b. What are those? 1, minus 2 and 1. So it is x minus 2 by 1. Next we have y minus of minus 1 becomes plus 1 divided by direction ratio minus 2. Next we have z minus 4 we have, so z minus 4 divided by 1. So this is the Cartesian form of the given line. So thus in today's session we have learnt one of the derivation of equation of a line passing through the given point and parallel to the vector whose vector form is given by vector r is equal to vector a plus lambda b, and Cartesian form is given by x minus x1 by a, y minus y1 by b, and z minus z1 by c. So where a, b, c are the direction ratios of vector b, x1, y1, z1 are the coordinates of vector a. So both can also be expressed in vector form as well as the Cartesian form. And as I said, the derivation is very important for 5 marks in your examination. So for the derivation, you need to write the description first, then followed by diagram, then we have proof both in vector form as well as Cartesian form. So this much is required for 5 marks. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.